Hey guys, welcome back to another episode on the Python series. Today we're going to move on to something even more exciting than what we've been learning before, which is object-oriented programming, which is a programming paradigm that deals with something called classes and objects. So let's dive into it for the first time and let's learn all about it. So up to this point in this series, we've been using all kinds of built-in data types within Python for storing and working with data, right? So we learned about the basic data types like ints, floats, bools, strings, lists. We even learned about dictionaries, which is a way of modeling more complex data that goes together. But with classes, you can define a blueprint for modeling real world things or more complex things that you can't easily model with simple variables. At a high level, it's really just a custom data type for modeling complex things. So, what we can do is essentially define our custom data type or class as a blueprint, and then we can create instances of those classes that we have defined called objects, but it's an actual instance of the class blueprint. So just as a more concrete example, you can make a class blueprints for a car because the cars are pretty complex to represent. That's just the blueprint though. That doesn't actually let you create a car. So once you have your class blueprints, you can create things called objects from these classes, which are actual instances of the classes that you have defined. And so we can create variables just like before, but instead of storing stuff like ints or floats or any other data type that we learned about before, we store the objects of these classes. Before we make our very first class, it's important to know what a class is. So a class is made up of two things: attributes, which is essentially the data that you're going to be storing in the class, and then after that, you have methods. And methods are simply functions that live inside the class that specifically work with the data inside the class or do things specific to what the class is about. So again, a class is a blueprint essentially for modeling complex things. And then a class is made up of two things primarily, which are attributes, which is the data, and then methods, which are the functions or the things that the class can actually do. So with this combined, we can then, like I said, model complex real world things or just complex things in general that you can't easily represent with the basic data types that we learned about so far. So let's get started. Let's make our very first class so we can actually understand what the heck I'm talking about. So to make a class within Python, you simply type class, it's a new keyword, class, and then you want to give the class a name. And usually it's proper case, so you start with a capital letter. So if we want to model a car, we can do class car and then do colon. So there we go. We have our first class called car, but it's not useful if you don't have any attributes or methods. So the first thing that we'll learn is that there's a built-in method within classes in Python called init. So I'm just going to type it out. It's not going to probably make a lot of sense the first time you see it, but it'll make sense afterwards, I promise. So we're going to do def. We're going to find a new function within this class, and it's called init. And you can see that it's already suggesting it because this is something that almost every class is going to have. It's not required, but usually you have it. So if I click it, it auto-completes it, which is nice. And so we can replace pass with the actual code of the init method. So we'll say something like init has been triggered. So the way that this works is every time we create a new car of the car class, it's going to first run the init function, which is actually a method because it's part of a class. And right now we're just printing something out, okay? So I keep saying methods and functions kind of interchangeably. So we learned about functions before, which are groupings of code that have a name essentially within our program. And then methods now are functions, but functions within a class. That is the difference between a function and a method. All methods are functions, but not every function is a method. For a function to be a method, it simply has to be inside of a class. That's pretty much it, okay? Okay, so back to our class here. Now we have to think about, since we're trying to create a blueprint for a car, what does a car usually have? What are the attributes of car that make a car a car? So usually you're gonna have stuff like a make, a model, a year, stuff like that. So what we're gonna do is pass that data into our init function here, or method. So after self, and I'll explain self later, after self, we're gonna do make, model, and year. And then down here under the print, we're going to do self.make is equal to make, self.model is equal to model, and self.year is equal to year. So what this code here is doing is saying that every time we create a new car, we need to pass in the values for these three parameters here. Because remember, this method is called when you create the object. So then once you pass in the values for this method, this will be triggered. And what it's going to do is set the values onto the attributes of the car. So when you do self.make, self.model, and self.year, we're creating new attributes or the data of our car class. And I know it's a weird syntax. We've never seen anything like this with self.make, but that's what that's doing. It's creating new attributes that will be part of this car class, okay? For some of you, this may be an easy concept, but if you're a beginner to programming, this may be like, what the hell am I looking at? But I promise it will make more sense. Okay, so what we've done here is define the attributes of our class. Remember, classes are made of attributes and methods. Now we're going to define our very first method for a class. So again, the method is a function within a class. So we're going to do define, and we're going to do something simple like get description. And then here within the parameters, you have to type self. So we'll put self and we'll do colon, and we're just going to simply have this return a string. So return an f string with the data of the car. So we're going to do self dot year, self dot make, and self dot model. So this is going to return a string with the information of the car. I'll explain how it actually works in a second. But first, this is it. We have defined a car class. It now has attributes or the data of the class, as well as a method, a single method that returns information about the car as a string, okay? So once we have defined a class, we can actually start using it. We can create instances or objects of the class. So we're going to make our very first car. We're going to say my car is equal to, and then to create a new object of the car class, we simply do the name of the class, so car. And then now within parentheses here, you can see that it's telling you to pass in the data that we defined as parameters in the init method here. So this would be the make, the model, and the year. So I'm simply going to say Tesla Model 3 2025. And that's it. So what we've done here is create a new variable, same as always. But the value of this variable is going to be an object or an actual instance of the class. So the class is just a blueprint, and the object is the actual physical representation of that blueprint, essentially, okay? And we can do another one. So we could say car2 is equal to car, and we could define a whole different car. So we can do Toyota, Camry, 2003, something like that, right? Now we have two completely different objects of the car class. So as you can see, they're both cars, but they're totally different cars that live in your computer's memory as the program is running. So again, I'm going to repeat myself a lot. The blueprint is the definition, and when we create objects, that's an actual physical representation of that definition that we've created. So this first object that we have, this my car variable, stores the first object, and it has the value of Tesla for the make, for the Model 3, and then 2025, and then for this one, Toyota Camry 2003. So let's go back to the class definition now so we can understand a little bit better what the hell's going on. The first thing that you'll notice is that we keep using self, and we're passing that in as the parameter for every single method that we have within the class. Self is a way of the class being able to refer to itself. That's why it's called self. So in this case, when we create a new object of the class, we're passing in the make, model, and year, and then we're going to use self to do self.make is equal to make. Now at this point in time, make is not a thing. So what this does is defines a new variable called make as part of the class, and we're assigning it the value of make that we passed in. So this is the parameter variable called make, and this is the class variable called make. These are totally different. It's common to use the same name because we're passing in data for make that we're going to be storing in the variable called make. So it just makes sense for it to be the same name. And then the same thing for model and year. We're creating a new variable called model and a new variable called year and giving it the values passed in when you created the object. So this is the most common thing that you'll be doing with init, is passing in the data that will serve as the values for the variables of the class, or otherwise the attributes. So now that we know what this is doing here is it's creating new variables, we don't actually have to create it based on the values of the parameters that are passed in. We can just create them flat out. So we can do self dot, and we can say, for example, speed. We can set that to 0. And this makes sense. Whenever you create a new car, ideally the speed will initially be 0 unless you change the speed. So this is not something that we have to pass in usually. You could make it that way. You can pass in a variable called speed, but you can also just do self.speed is equal to 0. So every time you create a new object of the class car, it's going to have an initial speed of 0. So we have these two objects down here called my car and car2, two different objects with their own set of these variables here. So they all have make, model, year, and speed, but they all potentially have different values, except for speed. So each of these objects internally has their own variables, make, model, year, and speed. I really hope that makes sense. And then also we have this code here I forgot about. We're printing out the message, and it has been triggered whenever we create the object, because this runs at the beginning. So let's run it and verify that fact. There we go. And it has been triggered, and it has been triggered. So you can see that it was called twice because we created two different objects. Then we go here to the class function that we've created, or the method. You can see that it passes in self just like the init did. This is a requirement of every class method that we create. Now technically there's functions that can live in classes that don't need self passed in, but we'll focus on that later. So for now, every single method that you create part of a class, you have to pass in self. And this is useful because then we can access the variables of the class as well as set variables of the class. So in this case, we're creating a new f string and we're using self.year, self.make, and self.model. So we're accessing the values of these variables that live within the class, combining it to a single string and returning it. So in this particular instance, self was useful to access the data of the class. or the object. So once you have an object of a class and the class has a method within it, how can you actually call it? How can you use it? So let's do it for my car. So we'll do my car, and then it's simply the same as before with any other data type they have. Like for Extreme, for example, let's just dot. So dot, and then we have get description. What this does is calls the get description method of the car class, and it tells you the return type, which is a string. So we're just going to take this and print it out directly. So let's run it, see what we get. So there we go, we get 2025 Tesla Model 3 because like I said, it was able to access the data of the object through the self variable here. And then let's do the same thing for car 2. Let's replace it. Car 2 has different values for these variables that live within the class, so we'll get different results. 2003 Toyota Camry, nice. So I really hope you're following up to this point. We've learned that we can create classes. We learned that we can create data within the classes, or basically just variables that live within classes called attributes. And then we also learned how we can create and call methods that live within classes. Something else that you can actually do is access the variables of the class directly. So we can do, for example, my car dot, and you can see that not only do we have access to the method, but actually the internal attributes as well. So we can access the speed if we want to, and we'll print it out. So print out the speed, it should be 0. There we go, we get 0. Now, usually the proper way to access attributes of a class is through a method, and we'll talk about that later. That's called encapsulation. But you can do that if you want to. You can just directly do mycar.speed, and it gives you the value of the variable that lives within that object, which is pretty useful. Now let's create some new methods for our class. Let's think about if we're trying to model a car as a data type. We have what a car usually has, so the data of a car, like a make, model, year, and speed. We have a description, that's kind of basic. What else does a car do usually? Now we have speed, and it doesn't change though. It's just assigned to 0 by default when you create the object, but it doesn't change. So how about we create some methods that live within the class that can affect that speed? So we can do define, and we'll say accelerate, pass in self, don't forget self. And then within accelerate, we want to increase the speed, right? That's what accelerating does. So to do that, we can do it through self. So self dot speed. So we're accessing the speed variable that lives within the object. And then we're going to basically increase it by a number. So we'll do plus equals, let's say, I don't know, 10. So we've increased the speed of the object by 10 when you run this. And then we'll also print out a message so we know it's been ran. So we'll do a f string. We'll say self.make and self.model is accelerating. And then we'll do the exact same thing for decelerating or braking. So define break self, and then we can do print, and then we'll do self.speed minus equals 10. So now we're decreasing it by 10. And there we go. So now we have defined 2 new methods that live within the car class. So that means that we can call them on our objects now. So we'll do something like this. We'll print out my car is going my car.speed miles per hour. So we get the initial speed of the car, which should be 0 at this point. And then we'll do my car.accelerate, and then we'll do my car. Let's do it again. Let's do accelerate again. So we're going to accelerate twice, and then we're going to confirm the new speed of the car, and let's see what we get. There we go. We get my car is going 0 miles per hour. The Tesla Model 3 is accelerating again, and then we get my car is going 20 miles per hour. So that makes perfect sense, right? Because we define the method to increase the speed by 10 every time we call it. And of course, just to double check, let's make sure that when you call the method on the myCar variable that it's not affecting car 2, because they're 2 different objects, and it does not. There we go. We can then also call break on myCar, so myCar.break, and now it should be 10. There we go, my car is going 10 miles per hour after braking. The last thing I want to show you guys is how you can change the value of an attribute outside of a method. So right now, as you can see, we modified the value of the speed attribute on the object within a method, but you don't have to do it like that. So for example, before we were doing mycar.speed, you can also do mycar.make is equal to 4. You can change the make, or you can change the speed. So you can set the speed to 20 manually if you want to, like that. This is perfectly valid code, and you'll see this in many places. The more proper way to do it, as we'll be learning, is that you should usually change your attributes as values through methods, because you tightly control the logic that is run to validate the change in values. That way it's not just you changing it to whatever you want without any rules. So now we've created a very first class. We've given attributes or data, and then methods, which are functions. We also learned how to create objects of that class. Now let's just go through one more example of a class that you can create, just so we can get enough practice since we're learning this for the first time. So we're going to make a new class called bank account. First things first, make sure to give your class a init method, because this defines what logic is called whenever you create an instance or an object of a class, right? So for this one, it can again be whatever you want. You can run any code that you want inside of here, but the most common thing that you'll do is initialize the attributes of the class. You'll create them and give them values, okay? So the attributes that I want is the owner of the bank account, and then another one could be the balance. So every time you create a new class, you want to think about what kind of data represents the class. What makes a bank account a bank account? You're going to have information like the owner and the balance being the most important one. And we can also do things that we do with other function parameters, such as setting default values. So we're going to say if the balance is not passed in, we're going to set to 0 by default. So you can reuse all of that stuff that we learned before. So once you pass in those values when you're creating the new object, you can then set them by doing self.owner is equal to owner, and then self.balance is equal to balance. So now every object is going to have their own owner and balance depending on what you pass in. Now let's go ahead and add some methods to this. So we'll do define deposit. So we need a way to add money. So we'll do self. And then let's add a parameter to this. So just like with the net, you can add parameters. You can also do the same thing with methods. So we can do an amount, for example. And we can do self.balance plus equals amount. So we're simply increasing the balance of the account. Pretty simple. And then I'll print this out as a confirmation. Deposited amount to owner's account. New balance is self.balance. If you look closely here, we're using amount by itself, and then self.owner and self.balance. So just remember, anytime you do self, this is accessing the attribute of the object that you're working with. So it'll be the current object's owner or the current object's balance. And then amount, since it doesn't have self.amount, it's just going to be referring to the parameter that you passed in. All right. Let's add another method. We'll do define and withdrawal. So you can take out money from your account. So we'll do self and then amount. So we can keep it simple. We can do self.balance is minus equals amount. But what you want to do here usually with these methods is validate the data that is being passed in, right? You want to make sure that things are happening as it should be, right? So I want you to just kind of pause and think about what kind of values would be invalid to pass into this withdrawal method. What would not make sense, right? So the first thing that I would think of is that what if you pass in a negative number? That doesn't really make sense. So we can start up here actually. If the amount is less than 0, we're going to say print 0 or positive. So if it gets to this point, it's going to run this message here. But since we're not returning out of the method, it's just going to keep going to the next line and run these pieces of code here, which we don't want. So what you could do is take this and put into an else. That's valid. Or you can do an early return. So you can return out of the entire method like that. So it prints this out, returns, and then we're going to the next part here. Okay, so up to you how you want to do it. And then we'll copy the same thing for our withdrawal method because it doesn't make sense to withdraw negative money. So invalid amount provided must be 0 or positive. Now, another thing, if you think about it, that you want to validate is to make sure that the amount that is passed into withdrawal is not greater than the amount that you have. Because how can you take more money than you even have in your account? So that's something that we definitely want to check. So we'll say if amount is greater than self.balance. So if the amount that you're trying to withdraw is greater than the balance of your account itself, we're going to tell them that. We're going to say insufficient balance. Owner has balance in their account, so you can't take out more than you should. And then you can do return, or you can also, like I said, use else. So it's a little bit cleaner, I think, in this circumstance. So we can say else. There we go. We're taking the money out, and then we'll have a confirmation. Okay. And I think this is it for this class. I think it's a pretty solid class. We have a class called bank account now that represents what a bank account is. So I really hope you're able to look at this and see the benefit of classes, right? You could use a dictionary, kind of. You can use a dictionary to combine an owner and a balance into one sort of variable. But then if you want to do anything more complex than that, like we're all doing here with methods and stuff like that, and just overall, it just doesn't allow you to do the things that you can do with classes. So yeah, it's definitely really, really powerful. So now that we have our bank account, let's go ahead and create some new accounts and just test it out. So we're going to say account 1 is equal to bank account, and then we can pass in my name, or we'll just pass in John Doe, and he's going to have his bank account with an initial deposit of $1,000, account 1 dot balance. So creating a new account, printing out the balance of the account. Then we're going to modify some things. So we'll do account 1 dot deposit. We'll deposit 500, and then we'll do account 1 dot withdraw. We'll withdraw 200, and then we'll print the balance again. And yeah, let's just take a look. Let's run it. See what we get. All right, here we go. Balance is 1,000. So that's when we create the account. Deposited 500 to John Doe's account. New balance is 1,500. Withdrawal 200. New balance is 1,300. Balance is 1,300. That's the final balance. Now let's modify withdrawal to take out 2,000, which should hit this one here because they don't have $2,000 in their account. Let's run it. Insufficient balance. John Doe has 1,500 in their account. Cool. So our validation is working. So the reason that validation is so important is, one, yes, you want to make sure that stuff that shouldn't happen does not happen when you call your methods. But also, if you were to just do something like this, account 1 dot balance is equal to, or minus equals 2000, since you are now directly modifying the value of the attribute for the object here, you don't have all the validation here. So it's more proper to call the method, because then you can rely on the validation to make sure that things are happening as they should. Okay, I really hope that makes sense. So as a general rule, try to make a method that wraps anything that's changing an attribute's value. That's just a recommendation. You're not always going to see that, but it's good practice. Okay. Let me know if anything's confusing. It'll make more sense though as we keep going, as you keep getting more practice working with classes. But leave a like if you liked the video, subscribe if you want to see more, and peace.